Hello, welcome back to Piers Rocks. This week I wrote a Diagnostics ROM for these disk drives. Simon Says start with why. I had intended this week's episode to be me fixing this 3040 disk drive, but it turns out this is the disk drive from hell and it's a massive pain to get working. So I figured having my own Diagnostics ROM to give me more details about what was actually going wrong with the disk drive would help. In this video, we're going to look at how to use the ROM, the tests it performs, and how it shares the results. I've put the 6502 assembler source code, the pre-built binaries, and the instructions for using these ROMs on my GitHubs, linked down in the description. So I have a disk drive in pieces in front of me, primarily because that's easier to show you what's going on. The motherboard I've got here is my working 2040 motherboard. I'm going to save a deep dive into the technical architecture of this disk drive for a future video. But for now, primarily what you need to know is that the main processor for this board is the 6502 here. The ROM chips for this drive get installed in these locations. These are known as RIOT chips, the 6532 chips. They provide a small amount of RAM, which is used for the 6502 zero page, input-output function, and timer function. We've then got static RAM over here and a secondary 6504 processor and some other gubbins over here. Right now my ROM only deals with the primary processor and circuitry and not the secondary processor. In order to run the diagnostic ROM, all you need is a 6502, the diagnostic ROM, which we'll install here, and one of the 6532 chips. In fact, you don't even need this 6532 chip, but this chip drives the LEDs on the front of the disk drive. So without this chip, it's quite hard to see what's going on within the diagnostic ROM. So let's take a look at the diagnostic ROM in action on a fully working motherboard. I install it in this location, which is the F1000 hex location, the high ROM location. And then I power the disk drive on. So when I power the disk drive on, things are going to happen pretty quickly because the ROM runs through its tests very quickly. I try and keep up with the commentary on what's happening. First thing that happens is the LEDs will all come on and then go out. It then tests zero page. It then tests static RAM, which it's doing now. Then it checks the hardware configured device ID, and then it pulses it out using the two drive LEDs. So we're now seeing 8 pulses followed by a pause. That's indicating this drive is configured for hardware device ID 8. So now let's simulate some failures on this drive. The zero page, the 256 bytes of zero page, is made up of 128 bytes from this 6532 and 128 bytes from this 6532. I'm going to remove this one to simulate a chip failure, and then we'll see what the diagnostic ROM does. So we turn it on. Again, we should see the lights come on, then go out. Then it tests the zero page. And we are seeing that the diagnostic ROM has detected a problem with the zero page of this drive, which is great. Further, because it's flashing this drive LED, it's the right-hand 6532 where the zero page static RAM has failed. If this LED were flashing, then the RAM within this chip had failed. Next, let's simulate a static RAM failure by removing one of the RAM chips. So the static RAM in this drive, there's a total of 4 kilobytes of RAM, and that's configured as pairs of 1 kilobyte 4-chip static RAM chips. And these are all located at different locations. So this is located at 1000 hex, 2000 hex, 3000 hex, and 4000 hex. I've removed one of the chips located at 2000 hex. Let's turn the drive on. So again, we see it testing zero page first, then it moves on to test static RAM, and it's hit a problem. And because this light is flashing twice and then pausing, we know it's the second bank of RAM, the 2000 hex location, where we have a problem. Now I actually have a failed static RAM chip from my 3040 that I've been diagnosing, so I'm going to install that instead in this socket and run the test again. So it gets on to testing the static RAM, and again it finds a problem with this static RAM chip and blinks this LED twice. I haven't yet added code to the diagnostic ROM to identify whether it's the high RAM the high 4 bits or the low 4 bits that have failed. That is possible, so something I may add to this ROM in future. Finally, what I wanted to show you is something I thought was pretty neat, and that's that the stock DOS1 ROMs have the capability to load a diagnostic ROM if it's located at the unpopulated ROM socket. This is D1000 hex. I believe the DOS2 ROMs, you had 3 ROMs installed, so this socket wasn't free, but DOS1 did allow you to install a diagnostic ROM. So let me just boot up this disk drive with just the stock ROMs installed and show you what it does. All 3 LEDs come on, then it goes off. It's now happy, it's running. I'm going to install my diagnostic ROM. This is now built for being located at D1000 hex. And let me turn the disk drive on. So now we see the LED sequence from my diagnostics ROM. What happens in the stock ROM is it first tests 0 page itself, then it looks for the presence of a ROM at D1000, and if it's there, it jumps to this ROM. So this ROM has now taken over and is running its diagnostics routine. When running in this mode, I'm not actually bothering to run the 0 page test because the stock ROM has already done that, but I'm running all the other tests, and you can see the drive has now stopped and it is flashing its device ID. So to run this diagnostics ROM, if you have working DOS1 ROMs installed, you don't need to remove them, you just install this ROM in the empty socket. As I said earlier, the source code for this diagnostic ROM, along with pre-built images and the instructions to use those or build them yourself, should you so desire, up on my GitHub account. I think I'm highly likely to be enhancing this diagnostic ROM in the future as I try and diagnose and fix more of these Commodore IEEE disk drives. So there you have it. This ROM has definitely come in useful in helping me diagnose and fix this 3040 disk drive, which is well on its way to recovery and will hopefully feature in a future episode. And I plan for this diagnostics ROM to be my first port of call for fixing my remaining Commodore IEEE disk drives. I would love to get my hands on the original Commodore DOS1 diagnostic ROM, so if anyone knows of its whereabouts, please do comment down in the description where I can get hold of a copy of that from. I hope you found this video interesting and useful. If you did, please stick around. Till next time, rock on.